All right, hi everyone. I can see people starting to join us. So this is the final webinar in this series by Cosy Homes Oxfordshire, and we'll be exploring insulating our homes for the next hour. We'll just give everyone a minute or two to join us here. If you've been here before, you'll know the script by now, but do please go to the chat channel whilst we're waiting, giving everyone a couple of minutes, and let us know your name if you're here with an organisation, a community group. Just helps us to know who we have with us behind the screen in this lovely virtual world we're still living in. And yeah, we'll just give it another 30 seconds or so for people to join us. All right, hi Alan, nice to see you again. One of our regular attendees. And Len's here wanting to reduce his carbon footprint. Brilliant, hopefully we can help you with that. Or yeah, point you in the right direction anyway. And Andrew, hello. Brilliant. Oh, lots of people saying hi. Brilliant. Hi, everyone. All right, I think we'll get started and people can trickle in as they join us. Great. All right, so thank you for joining us this Tuesday evening for a Cosy Homes Oxfordshire webinar. So in the next hour, we'll be giving an overview of how insulation can improve the energy efficiency of your home, lowering energy bills and carbon emissions, as well as, importantly, for the time of year we're coming into with temperatures rapidly dropping, improving the comfort and the coziness of our homes. So just quickly, for those of you who aren't familiar with what we do at Cosy Homes Oxfordshire, we are a one-stop home retrofit service working to improve the energy efficiency of homes across Oxfordshire with a whole house approach. And this approach often includes insulation because, you know, even homes that already have insulation can usually benefit from topping up. And if you want to know more about home retrofit generally and more about Cosy Homes Oxfordshire, then I would recommend checking out the recordings of our previous webinars in this series, which you can find on our YouTube channel. Last time, a fortnight ago, we dove into the topic of heat pumps, which is a really interesting one. And before that, we looked at retrofit as a whole and its importance within the climate emergency. So yeah, you can just search Cosy Homes Oxfordshire on our YouTube channel to find those. But back to tonight and to the topic of insulation. So this evening, you should be able to see on your screen our two speakers. So this evening, we're going to be led primarily by Paola Sassi. So Paola is an architect with around 30 years of experience in practice, and more than 20 of those years have been focused specifically on developing energy efficient and sustainable design solutions. Paola also has an academic background, having published several renowned articles and chapters in the field of sustainable architecture, as well as teaching postgraduate programs on sustainable design at both Cardiff University and at Oxford Brookes University. And alongside all of that incredibly impressive work, Paola also works with us at Cosy Homes Oxfordshire as one of our expert retrofit coordinators. And we'll also be joined later in the webinar by Tim Lunel, who you'll recognise if you joined our last webinar on heat pumps. So Tim is also really experienced in the energy and home retrofit sphere, having previously been Chief Executive at the National Energy Foundation, as well as currently working with the Microgeneration Certification Scheme, which verifies the quality of small-scale renewables. So tonight, Tim joins us as a homeowner who's recently had his home retrofitted, and last time Tim shared his experience with having a heat pump installed, and tonight he'll be telling us about the insulation side of that project, which really complemented the heat pump to ensure that his home is as energy efficient as possible. So that's the introductions, and I'm going to hand you over to Paola in just a second, but first, those usual housekeeping points. So firstly, we will be recording tonight's webinar. You're all off camera, so you don't need to worry about appearing on the recording, but we will circulate that recording to all of you later this week, and it will also be available on our YouTube channel with all the other recordings. And then secondly, please do continue to use the chat function throughout the webinar if you have any questions or comments. We've factored in time for questions, so if you have any, we'd love to hear from you. And with that said, we'll get started. So I'll pass you over to Paola. Welcome, Paola.
Oh, hello everyone. I'm going to first try to make this whole screen. Excellent. So I'm going to try and outline the sort of benefits of insulation and what you can do. So I'll start with an introduction of insulation and then look at some pitfalls and really look at how you would be insulating roofs, walls, and floors, and just a few notes at the end about grants. And I do apologize at the start because it may be too techy or it might be too simple for some people, depending on your background. But this is hopefully going to give you an outline, etc., and help you on. So first question really is, why should we bother? And this is quite important to understand. So what goes behind everything that we propose is actually been researched, and we're looking at about 30% of carbon associated with housing. And of that, we find that if we look at the existing building stock altogether, 60% is for space heating. So space heating really is the main thing that insulation can address. And once we convert it to carbon emissions, about half the carbon emissions of housing are associated with heating. So that's really an important aspect to address. And typically, when we're looking at sustainable and energy efficient buildings, there's a sort of three-stage approach to address housing and indeed any type of building in terms of energy efficiency. And the first thing is really getting the fabric right, which means insulating the walls, roof, floor, windows, etc., making it airtight. And if you're building new, obviously you can include passive solar strategies. What that does is ultimately reduces the amount of heating that you need and allows you to use more efficient services. So for example, Tim has got an air source heat pump, which will actually work best if the envelope of a building is well insulated. And if you insulate it to the extreme, you can actually do away with central heating altogether and use mechanical ventilation with heat recovery. So when you insulate, you're doing the first thing to minimize everything that then follows on. And once you reduce all your energy consumption for heating, etc., lighting and appliances, if you can put renewables, they can have a bigger impact. They can either cover everything or at least a bigger percentage of the energy consumption. So the first step is really the insulation. And it's also worth saying that obviously the insulation is going to last the life of the building. Services tend to last 5, 10, 15 years, but fabric insulation is there for windows 25, but on walls and roofs, it could be the life of the building. So good investment in that sense. So how far can we actually improve buildings? I'm sorry for the quality of the slide, but on the far left side, you have the existing UK building stock, and the red is the space heating, yellow is water, and blue is lighting and appliances. And you can see on the far right-hand side, you have the German Passive House standard, ACB Gold standard, and somewhere in the middle is where we have current building regs. So the red can be reduced by 80, 90%. And so, you know, it's worth doing. Obviously, the question is, if you can't do the whole building, what should you do? And again, this is based on averages, the image on the right, which says the roof loses 25% of the energy, and in brackets, it says if you insulate it, you'll only be losing 8% of your energy through the roof. Obviously, that's just an average. And the image below shows different types of houses, flats, terraces, and detached and semi-detached houses. And this is from the Zero Carbon Hub, and they've calculated that if an advanced sort of construction system were to be put in and applied to flats, terraces, and semi-detached, you could actually reduce the energy consumption to 39 kilowatt hours per meter squared per year for flats and the mid terraces, because the configuration is different. So the end terraces would actually end up consuming a little bit more energy, and semi-detached the same. And the fully detached would actually need a slightly better construction to achieve the same standard of 46 kilowatt hours per meter squared. This is where it gets a bit techy. But this is a way we use standards to be able to measure how well we're doing in comparison to what is considered good practice. And the point here is simply that if you're in a flat, you might not even have a roof. So roof insulation may be irrelevant to you. While if in a bungalow, the roof may well be the most important thing to insulate. So you have to look at each case in its own way to assess what exactly should be done as a priority. The other thing is, how does insulation work? And really, what it does is just reduces the transfer of heat. And heat transfers through convection, conduction in solid materials, and radiation. An insulation material really works on reducing the transfer or slowing the transfer through conduction, and different types of materials reduce heat transfer through radiation. And I think I'm not going to go into this, but if you've ever come across the term thermal mass, it's not the same as insulation, and it's a quite complex system to consider. So these are the, in principle, material methods. And then obviously there are different material types which are available. And they can broadly be divided in 4 categories, which are materials that are renewable, like timber, and starting from the left. Can you see my cursor, by the way? Okay, excellent. So this is, for example, cotton, recycled jeans, and sheep's wool. And then oil-based materials include expanded polystyrene of some shape or form. This is a structural option, then beads. And then you have minerals such as sand and glass, which also generate aerogel, one of the most efficient options but very expensive options for insulation. And then you'll have come across radiant barriers, which are essentially metallic materials that reflect radiation, either inside the building or outside. Of those different materials, again, this is a little bit techy. I've put them in order of effectiveness. And at the bottom, I've added bricks, which are not very well at keeping the heat in. And it's the ability to insulate is measured in the amount of energy in watts that passes through a material with 1 degree centigrade or Kelvin difference. And so you can see that bricks are probably about 20 times less insulating than the typical insulating materials. And so if you convert that into how much in terms of thickness of insulation do I want to achieve let's say an ideal insulation value, it ranges from anything from 100 millimeters to 300. And just as a measure, as a sort of comparison, if you wanted to achieve that type of insulation with bricks, you'd have to have 5 meters. But of course, 5 meter thick walls, but it wouldn't work that way, because other sort of physical things would happen. So when we choose insulation, a lot of it also has to do with how much space do we have, because it may not be possible to add 300 millimeters in certain instances. The other thing to think about, and this is probably good news for people who don't have much space, is that the first, let's say 60 millimeters of insulation has really the biggest impact. So what this graph shows is the U value, whereby the smallest number is best, and the thickness of insulation. And so here we have 20 millimeters of insulation, and from 0 to 20, you're already reducing the heat loss quite significantly. But after a while, it sort of flattens out. And so if you don't have much thickness available to play with, it's still worth putting some insulation, but at some point you decide from practical reasons for a specific thickness. If one were to wonder why would anyone go this far, is actually because if you're trying to sort of move as far as changing heating system and maybe doing away with a traditional heating system altogether, then actually this sort of level of insulation is what is required. There are other things that you might want to consider, which is vapor permeability. This is important for older buildings because it allows the structure, the vapor to permeate through the insulation, and therefore the structure behind the insulation to dry out as required. Hygroscopicity is really the ability to absorb humidity, so that acts as a conditioning help for the actual interior spaces. And then also other things such as embodied energy, which is sort of quite important because some of our cheapest insulation materials like expanded polystyrene and extruded polystyrene is very effective, but also very cheap, but also has a really high embodied energy. And the embodied energy, for anyone who doesn't know what it is, it's really the energy required to manufacture that product. So what else to consider? There are a number of pitfalls that really should be avoided. One of the biggest when you're insulating anything is so-called thermal breaks, thermal gaps, whatever. It's basically where the insulation is not continuous, or you have a gap that allows the air, like in this case, badly insulated walls, or a gap where a junction of material with another material join up, and there's literally an air gap. This image here is actually of my one of my old house, which was retrofitted, and blue and purple is very cold, which means it's actually very well insulated. Red is terrible. Loads of heat spewing out of the front door because the front door had not been upgraded. But you can see also the neighbor's house on the right is totally red, which means that they're heating and all the heat is just going straight out of their walls, actually. So, but thermal gaps are where you can see the red lines around my windows, which is where when you're retrofitting an old building, sometimes it's difficult to actually get a very good thermal, uniform, thermally insulated fabric. And there are different ways, so we can come back to this if anyone is interested afterwards, but really thermal breaks are really problematic because if, like this example, you have the brick which has very little insulation, and then you end up with a sill that is touching the brick, you'll get a very cold spot, and that's where you get mold. So it's not just that you're going to be losing more energy, is that actually there's a risk of mold. The other thing is you can go over the top. I mean, this is effective and they exist as products, but you can see this is a fixing for external insulation, and it has a little plastic cap because the fixing is metal. And so it's effectively thermally linking and losing a lot of heat through that metal element. And so the little plastic cap is actually insulating. And it's also worth going back to the type of building. There are certain buildings that are more likely to have lots of problematic joints, like detached houses, compared to other buildings. None of them don't have any, but if you're in an apartment, it's less problematic. So thermal breaks, very difficult and important to consider. And the other thing is ventilation. A lot of what we do when we insulate can increase the risk of mold and rot. And mold and rot will only happen if it's cold enough, if there's enough humidity in the air, and if there's not enough ventilation. So when we're looking at, for example, this is a raised floor, we have to make sure that there's enough insulation at the bottom through the structure, underneath the structure, and similarly in a loft. And I'll go into a little bit more detail later. The other thing when we insulate, and Tim can say whether he's, maybe he hasn't had time to have experience yet of that, you may overheat. And so shading to windows may be required. So those are some of the pitfalls. And now looking at one element at a time, I think we're sort of all right for time for the time being. I thought I'd start with lofts, mainly because they're the easiest to deal with, and they do have a DIY. I mean, they can be done as DIY by anyone who's interested in doing DIY, really. Most materials can be used, but there are, for example, advantages of soft, squidgy materials because you can actually fill gaps more easily. If you use rigid insulation, it tends to then leave gaps. Also very important is to allow for ventilation of the roof structure, as mentioned before. And it's sometimes better to actually go and spend a little bit more money and use such things as rafter ventilators that the insulation doesn't basically close the ventilation gap. And if we're trying to aim for high, this little diagram shows how much insulation is really required. And we tend to, at Cosy Homes, recommend 300 millimeters laid over the structure and making sure that the gaps don't overlap. So you're not only increasing the insulation, but you're also reducing the ventilation drafts and those sort of heat losses. That's probably, I mean, we have a big variety of options, options for materials in a loft, which includes also things like recycled cellulose and any sort of natural materials, because there's very little risk of damp if properly. So really any material would be generally fine. Roofs can also be insulated in the line of the roof, and there it's probably easiest if rigid boards are used or semi-rigid bats. And again, in an ideal world, it makes no difference. We're still in an ideal world looking for 200 to 400 millimeters insulation, but obviously that's not always possible. So that's where we have to then start saying, should I use maybe a plastic-based insulation material that has high embodied energy, but we get a much more efficient structure in the end, or use something that is maybe more vapor permeable or at least hygroscopic, so it modulates the humidity. But in a way, as long as one of the issues to consider is what type of roofing membrane. If the roof is got a roofing membrane and it's ventilated, there is no real, and the job is done properly, there's no risk for using any types of insulation. They're all fine. Consider that if you insulate, this image shows it quite nicely. You want to create as much as possible an airtight structure. So this is a system where you can actually then tape around the wires and you're not losing heat straight through the gaps that will otherwise occur. The problem with insulating internally is obviously that if you are using the space, you have to move out of that space. So it's quite disruptive. And the other things to consider are obviously, it's not really DIY. This is why this image is supposed to remind me to say it's not really DIY unless you're good at that, and you can, because you will be shifting quite quite heavy boards and the like, so that has to be thought carefully. So this is a roof from one of our projects, and one of the things that can be done is that you can fill the existing rafters and then add rafters or timbers at 90 degrees to the existing and fill more insulation. In this case, there was a vapor control layer, which is with roofs quite good practice and not problematic. I'll explain later. And also you can see there's a little insulation on the side of the roof. And actually the wall in this case was also insulated because ultimately the neighbor might not have built out their roof and therefore it's cold. By doing this, you do actually achieve something like 300 millimeters of insulation. Moving swiftly to walls, one of the very straightforward ones is cavity wall, but it's not that straightforward. It's not a DIY option for sure. Any material that has to be that is used has to be inert, so no biodegradable materials are appropriate. And there's a sort of minimum cavity width of 50 mil. This, you can get a lot of, there are a lot of installers that can do that. You can come in, they can do a inspection of the gap of the cavity and check whether it's appropriate. If there is material that is damp inside, it really needs to be cleared out. So that's something to watch out for because the installers are not that interested. Not necessarily that interested. Also, it's quite, it can happen that the insulation can slump. So it has to be done properly, and you have to make sure that the company that does it is reputable and can give you a guarantee and so forth. The advantage is that the disruption is minimal. There's very little, unless you have to pump from inside, which does happen once in a while. It's straightforward. And we're finding at Cosy Homes that people are very reluctant to move their furniture. So maybe in this case, it's something good. As opposed to internal insulation, which does involve a lot of disruption. Really, the best thing is to empty the room and then do the work. If we do the work very well and carefully, if you're on the first floor, you really want to insulate the floor between the first and the ground floor. So not the floor itself, but the wall, which is hiding inside the floor. So you have to lift some floorboards and extend the insulation down to reach the ceiling of the floor below. We have a lot of different materials that can be used. At Cosy Homes, we do recommend, if it's a solid wall construction, to go for a breathable material, which is allows, so vapor permeable material that allows the vapor to go through the material. So if you're looking at a solid brick wall, which is very common in Oxford for sure, putting timber fiber will allow the brick to actually dry out to the inside of the building, and there's less possibilities of rot and spalling of bricks and basically damage to the wall. However, it should be any wall, if you're insulating it from inside, really needs to be in a good state of repair. So you first have to fix any sort of gutter problems or however the water might be getting in, and then you can start doing the insulation. So if you do internal insulation and it's timber, there is really a maximum thickness that is recommended. That is about 80 millimeters. If you think back to the graph I had, it still means that it makes a major impact on reducing your insulation, your heating costs. So it's good. It does take up a little bit of floor area, depending how much insulation you put. It's actually, as the concept of actually insulating the space inside the floor is there, because otherwise you would have a cold bridge. But regardless what you do, it's still more likely to have cold bridges, i.e. spaces that you just simply cannot insulate. So it's never going to be as fantastic as if you do external insulation, which is the next option. And the reason it's better in terms of cold bridges is that you're basically covering the wall, and all the structure is inside the insulation. So there can't be any gaps that are not insulated, because the whole thing is inside. I've shown here a number of different materials, including something which is called diathonite, which is insulation, which is cork and lime plaster mixed, which can be applied with a spray. And really, it's ideal for really uneven surfaces. It's reasonably good in terms of quality of insulation, but it's thinking again of historic buildings. It can really help those uneven surfaces, and it can actually be used as a base for other insulation material, or it can be used in its own right. This is all about timber fiber, and there are two different approaches. If you're insulating with timber fiber, you can render directly on it. If you're insulating with, say, rock wool, you have to put a mesh. So it's good for avoiding thermal bridges, increasing air tightness. Obviously, if you're doing it outside, there's no disruption. But because you're adding a layer to the outside, you generally have to extend window sills. You may have to extend roofs and so forth. So there's a little bit more extra work. This is another project where we've added it. This is more than 10 years ago, added a frame on the outside, filled it with, so to speak, Loft soft insulation, and then put glass wool on top. You can see all the fixings, and then it got rendered. So, and this sort of thing works very well when you have a building that really needs a lot of work done, and then this is an opportunity. Floors. Now, really, there are two types of floors. Generally, I'm living in a 1930s building which has a concrete floor, but anything older often has a suspended timber floor. With concrete floors, the first option is you dig it up. No one is really keen to do that. It's quite expensive and very, very disruptive, and your neighbors will not like you much. But again, going back to that graph that I showed at the start, if you even just add 50 mil of insulation, it will actually make a big impact. So the other option is to actually add the insulation on top. That's actually quite easy. It could be a DIY option. I would not put natural materials that could biodegrade, because you do need to put a not a damp-proof membrane, but you never know, it could get wet and then they will rot. I would put some inert materials, and they have to be rigid, because you'll then put a floor finish on top. The problem with adding an additional layer on top of the existing floor, of course, is that all your doors have to be cut back. You might end up having problems with headroom, and that has to be considered right at the start. And inevitably, you will have to empty the whole place. So it's quite disruptive. It's still very disruptive, even if you have a timber floor, suspended timber floor, except that new technology has come along. And so this image is of a little machine, a little robot called Qbot. And if you have 150 plus space between the bottom of your joists and the ground, this little robot can be directed to actually spray insulation on the bottom of your floor without having to take everything out. Now, that's amazing. I haven't seen it in action. The material is obviously an oil-based, and it's a spray-on thing, and we don't know how long it will last, but it's probably going to give you a very good U value, so it will be very insulating solution. The alternative is that you take the floor off and you actually add insulation in between the existing joists, whether this image right at the top is using rigid insulation. And so what the person is doing there is actually they're taping the gaps, because otherwise there would be air passing through and losing all your heat through ventilation or infiltration losses, as they're called. This is another image where this is my poor brother being coerced in doing work for me. The whole floor was lifted up, and we put new and actually put little boards, waste material, to make sure the insulation didn't sag. But importantly, you need to make sure that there aren't any gaps. So all the edges have to be carefully filled with insulation, and it's a huge job, but you can do it if you have to lift the floor anyway. What can you do if you do everything? The bits and pieces that I've shown you is actually from this house, and it was in a really bad state, but you can actually reduce the heating energy. It was reduced by 80%. So you can make some massive changes if you have the time, and the building to start off with is a disaster zone. Then it's easier to make a big impact. So that's the sort of very quick review of what you can do. There are a couple of grants. You will have all heard about the Green Homes Grant, and really insulation is a primary measure. So you should be able to actually apply and get money to cover 2/3 of your cost, up to £5,000. There's also the Eco scheme, which is really for low income and vulnerable households, but still it's the same. Well, it's not the same. It's a source that will be usable for people who qualify for the scheme. And it's again insulation, mainly cavity wall, and some loft, because they are the simplest and least disruptive in a way. And I've also added at the back of sources of information. Energy Saving Trust is fantastic at just providing general information, but the Zero Carbon Hub has more more research-based information, and obviously National Insulation Association is what it is, and the Cavity Insulation Guarantee Agency is one of the possible agencies that provides guarantee. But you can see, if you're interested in getting cavity wall insulation, that you can see what they cover with their 25-year guarantee. So that's really it from me. And I guess I will stop sharing, and we can have questions, or Tim, if I can manage to stop sharing and hit the right button.
Thank you, Paola. That was brilliant. Really interesting overview. We've had a couple of questions, let's take a couple of questions now, and then go to Tim, and then we can always go back to questions at the end if we need to. So we had one question really early on about insulating doors and windows, which I think you kind of highlighted with your thermal imaging photo, that that's important as well. I don't know if you have anything else to say about doors and windows and insulation.
Yeah, I mean, the general idea is that the doors and windows, the frames of the doors and windows should be connected to the insulation. So that the idea is, when you're trying to avoid cold bridges, is that you should be able to draw a line around the whole building without lifting your pen linking all the insulating elements. And windows and doors are effectively insulating elements. So for example, around a reveal, you might actually use something like aerogel if you don't have much space, or you're leaving the existing windows, which may open. Well, if they open out, it's not so difficult, but you don't have much frame space to put a lot of insulation. So either polyurethane or polystyrene or aerogel insulation will give you a good insulating value with very little thickness. So really the rule is make sure that your frames are linked to the insulation of the walls. And yeah, if you have space, you do whatever you like, but if you don't have any space, then the more insulating elements will be helpful. I hope that answers it.
Great, thank you. I think it does. And then we've had a question from Robin about, can you say anything about improving the performance of existing loft conversions?
Yeah, there's no difference really to if you have an existing loft conversion or an existing building. You have to try and find out how much insulation is there. But if it's an existing loft conversion, the assumption is that the roof is well ventilated. And so one way is to simply insulate, put additional insulation internally. I mean, the other option is obviously you take off the roof and you see what's happening. But if it's a reasonably recent loft conversion where you know that the roof is well insulated, that the roof is well ventilated, sorry, between the tiles and the insulation, then you can either remove the plasterboard and add, like my image where I had cross battens, or you could add insulation fixed straight to your structure and then again put plasterboard back, or you could even just insulate on top of the plasterboard. It's not as good practice, but obviously it's less work.
Great, thank you. Robin says thank you as well. I'll do one more question now, and then we've had a few questions which are about specific people's houses and cases, so I'm thinking maybe we leave those to the end and we could have a bit more of a discussion there. But the last quick question was, what's the best way to ensure airtightness? Is it a case of militantly taping and filling everywhere?
Yes, that is, bottom line is that exactly that. And if you are adding new insulation, then it's easier because you have those junctions that you are creating afresh. And so you make sure that you have a tape that is good quality. I haven't gone into this, but there are different types of tapes. You have to get the right one because it has to A, stick to the insulation, and B, stick to whatever you're sticking it to. And generally speaking, there are, I showed you an image earlier with that tried to separate or give you a service void, because one of the big problems with air tightness is that you do all your work and then the electrician comes along and says, ooh, I'm going to just poke a hole through that fabric and run a cable or a pipe, and then they just walk away and you're left with this hole there. So if you preempt that by actually allowing the basic structure to be well insulated, then to the inside you have a gap for the services that will help the air tightness a million miles. And also try not to put, what I did once years ago is to end up with a hole which was in the ground, but it was still a hole which I couldn't get to. And even holes in the ground will actually essentially cause you to be not as airtight as you should be. So thinking every step through is what we need to do.
Yeah, I guess quickly on that, Rico's asked as well if chimneys are a major problem to air tightness and if they could be part of the solution or if they need to go. And I guess that's that same whole issue.
I mean, I think they don't necessarily have to go, but they need to be, again, we have suggested people to put these sort of chimney sheep, which is basically, or chimney balloon or other ones, just to close it off. I think what you have to do though is keep in mind that you don't want rain to come in and then make the inside of the chimney damp, and then you have moisture in the building, which is problematic. So really, when you're closing a chimney, you really need to stop the water getting in. You may still want to ventilate it, but at a much smaller scale than the big sort of fire opening that is otherwise required. If you can take it out, I would take it out, but it's a lot of work.
Yeah.
In actual fact, actually, I'll add something. I am looking at closing the top of my chimney on the roof level and filling it with vermiculite. So that's an insulation material that is very resistant to damp, and that's one option. I think I'll probably do that myself.
Brilliant, thank you. All right, let's hear from Tim about his retrofit and improving insulation, and then we'll come back to some of the remaining questions at the end. All right, Tim, over to you. Oh, you're muted, Tim.
Still that? Yeah, grand. I'll just put this up. I mean, I would say that given Paola's fantastic presentation, I will make it quite whizzy, I think, because we've also got lots of questions to answer. So I think I'll make it whizzy. If anyone wants to ask any more questions at the end, we can do that. But this is one particular one that kind of, why is it that we looked at the insulation as part of it? Interestingly, one of the major drivers was actually us wanting to put an air source heat pump, move off, because we're not on the gas grid, so it was actually on oil, the sort of the highest carbon intensity fuel we could have. So we actually wanted to move away from that and to have our house so you could actually get the heat load, the effectiveness that Paola mentioned earlier. It was actually important to insulate. So that was the initial driver. But then there's also, there are areas of the house where we really got too hot in the summer, so I will come to that later because we've already seen the effect of that, and definitely too cold in the winter. And the main bedroom, which is actually where I'm at the moment, that kind of really lacks on the installation. I'll describe that a bit more with the pictures in a minute. And it's kind of particularly the rear of the building really wasn't well insulated. So I'll describe that in pictures. So this is the rear of the building. So the front of the building is solid ironstone, and then the back of the building, these are cavity walls here and here, and I did have those filled a few years ago. There had been some stumping that went on, so got someone in to go and get that sorted. This central portion then was added at different stages, and this was sort of done in the 70s, and it had some very poorly insulated and full length double glazing doors here, and that had the effect where basically in the summer it gets, because it's a south facing, got very hot, and in the winter got very cold, to the extent where we quite often actually just closed these doors off and didn't use this room when it got very cold in the winter. So that level. The thing which I found most interesting going through the Cosy Homes process was then this area here, which we added in '96. This was an open balcony before then, and is now the main room and has views out, which you might have seen earlier before it got dark. And so it's a room that we really like, and it's one of the rooms we really like in the home. But actually, this was built in 1996. We kind of thought at the time, this was before I was in the energy and buildings area, or for meeting 1996 building rigs. Then in our home, which is got areas which are pre-1900, then clearly it's going to be very, much more well insulated and won't be an issue. Well, Cosy Homes was, we kind of were feeling that there were some issues there. And again, the surveys that we have with Cosy Homes did very much point to the fact that this needed to be addressed. And so you can see that that's exactly what we've done in this bit here. The wood cladding got taken off right back down, and wood fibre as the basis there, some fall back underneath to make sure we had the depth as well, but extensively changed the insulation here. And then here, these windows were taken out, and what you can see on this side is we've now got thick, or I was trying to remember what the thickness is. I think it's 200 mil. It might be more than that, thick walls now with combinations of insulation on the outside and breeze blocks and things to make sure the U values are right down for these walls. And what that now has meant, I think the biggest change in sort of look and feel is in this room down here. Let's move that So I can see, so in this room down here, which has now become our kind of our kitchen area, and already we have seen that that is then doesn't get overheated when you have the full south-facing sun. We get fantastic still light through here, and the kind of the feel of it is still very open. But it is one of those things which I know, particularly when it comes to passive house design, is one of the things that's looked at quite a lot. Is while you might think, oh, there's lots of nice light that's coming in here from the lower areas, that's the kind of light which then causes a lot of the overheating that you can get. So actually changing this to have this insulated has made a significant difference to how we can use this room. And as I said, I'm in this room up here at the moment. We've not got any heating at the moment, but it's just this stays so much nicer and warmer. And one of the reasons for that is the walls that we just talked about, where basically that timber frame was taken out and insulated. The other one, which I was kind of really pretty shocked by, was the kind of the ceiling. When you look at what was in the ceiling there of 100 mils of fibre insulation, as being between you and the outside wall as being the insulation, not really surprising that it didn't do what was needed, and therefore that was all taken down. And then there's a combination of fibre board with some insulated board below it. So it was. If people want the numbers, I kind of thought I wouldn't have to be doing the numbers because I was doing most of that. But I've got the details plans that we got through Cosy Homes, so we can go through that. That made a really big difference to the kind of the installation there, and the kind of the before and after. In one sense, one of the reasons for putting that up is, in one sense, the look of it. You kind of say, oh, what's happened here? And I've had interesting conversations with my mother about that. Oh, so how does it look so different? Well, actually, it doesn't look very different, but my word, does it feel different? And it now is a room which really doesn't get overheated with it being south facing, but also in the winter we're already seeing that we're not having to have the heating on at the moment, even with the air source heat pump, because it is really well insulated. So we did also we talked about change over to, so we've created this stocking great dirty size 1200 litre oil tank with now the air source heat pump. This whole area was replaced. I didn't mention, actually, it was a lower floor area, so we were able to put in a significant amount of underfloor insulation and put in underfloor heating. That is now a lovely room to be in the morning. That is one of the ones that does come on in the morning. That feel of the low level of heat, but coming through the floor is fantastic. So if you do that insulation on the floor, I would say definitely put it underfloor heating, even if you haven't moved over to air source ground source heat pump now. Get it ready for that in the future, because at some point we'll all have to switch off whether it's gas or oil, and having the underfloor in there really does help that in terms of an efficient way of heating. I was a bit of a whiz through, but I kind of, as I said, I really felt, given Paola's fantastic presentation earlier, we probably want to have more of a discussion rather than the individual bits. But any questions on that or any more details, very happy to share.
Brilliant, thank you, Tim. Just helps to put it into perspective a bit to see someone's home, so that was really great. We did have a question earlier, which I think might be useful to pick up now, from Robin, asking about whether there's any issues changing the appearance of your home with external wall insulation. I don't know if you came up with any issues with that, Tim, on your the back of your house.
Yeah, well, we're in a conservation area, and so certainly that the ironstone, we haven't got pictures of the front, but the ironstone front of the house, the only thing that you could put internal wall insulation, but one of the things, again, that because it's north facing, one of the bits that really works well when it's hot in the summer is actually having that large thermal mass that keeps really nice and cool. And external wall insulation, no. I mean, we're not a listed building, but we're on the kind of main high street, so we wouldn't be able to do that. The back of the house, that insulation, as long as it's in keeping, and that's the colour that was chosen there. And I've had different views of, some people like it, some people don't like it, but it was to try and have it as something that it wasn't trying to match the reconstituted stone that's on the back, but actually is a colour that matches the ironstone. So again, in terms of the planning and that side of things, that's fine. And certainly, it's one of those ones, if you're doing that insulation, there are planning issues, but we need to move that forward, because at the end of the day, we have to have homes that are fit for the 2030 and 2050, and it's how do you make that happen? So it is definitely something to take into account. But we have lots of homes in Hook Norton, which is a conservation area, work with listed buildings as well, and absolutely it can be done. It just needs to go through that step in that process.
Great, thank you. I think what we'll do is we've got a few minutes left until we kind of officially finish, and we've got a couple of general questions. So we'll take those now, and then I'll do some kind of the closing bits that I need to get through. And then there's a few people who've said they're happy to stay on and do what we did last time with the heat pumps and kind of get people to unmute and share their house issues, and we'll do a bit more of a discussion with those. But then anyone who needs to leave can leave. So yeah, just so you all know what I'm going to do. But we did, yeah, so general questions. We had a question from Claire about how you know if your cavity wall insulation has slumped and what you would do about it. Paola, maybe one for you.
Yeah. Well, if you remember the image, the thermal imaging camera image that I had of my house and the neighbor's house, you can actually, if you do that, you can see where the gaps are in the insulation. And actually, they're not necessarily always at the top. When they insulate with a cavity wall, it can be that they just miss bits. So you can actually, if you have a thermal imaging camera, you can take, it has to be during cold weather, you have to have a difference in temperature between the inside, generally the house being heated, and outside being cold. That's why they're generally taken at 6 o'clock in the morning, which is not the most sociable time of the day. But, and so, yeah, so you can find that out. And in terms of being slumped, that's a good way of doing it, but they can also drill a hole through gaps, through the mortar between the gaps of the bricks, and put a little camera inside. So you can do a boroscope investigation to see whether the insulation is sound, whether it's damp, whether it's full of rubbish or whatever.
And that's a very quick and easy, non-intrusive thing. That I said, I didn't have that done this time around because I did that about 10 years ago or so ago. We're just getting an installation company around that can just do a quick survey and have a look and see. And, you know, and it's not in their interest to, I mean, they'll provide you the images, but it's not in their interest to try and fill one that is already well filled. So, I think have them in, do that boroscope as well as the thermal survey, and it is a very quick and easy thing and relatively inexpensive thing to do. So if you've got cavity walls, definitely number one step to make sure that they're well sorted.
Yeah, great.
And the insulation is pretty effective. There's a debate about whether to put external wall insulation on top of that, the cavity wall, and we did the heat calculations, and it was kind of, in that particular case, for the amount of disruption for having to extend the roof out, which you'd have to have done at the back there, it wasn't worth it. But it's kind of, again, it's something you can feed into the calculations. And if you've got an area which you've got cavity wall insulation, but it's a particular area that might get cold, then you can put external insulation on top of that as well. And we did consider that.
I think, yeah, cavity wall, typically cavities are anything between 50 and 100 millimeters, really. So when you're trying to get really well insulated, you're not going to have enough space to put a lot of insulation there. So you can add it on the outside. And actually they do sort of recommend to fill cavities, even if you are going to put insulation on the outside, because otherwise you might have paths of air inside the cavity that will reduce the efficiency of that wall.
Great. All right, thank you for answering that one, both of you. We're at 7 o'clock, so I'll just do the kind of closing bits, and then anyone who needs to leave on time can do, and then we'll carry on answering questions and discussion bits with anyone who can stay for a bit longer. But yeah, just a huge thank you to Paola and Tim for joining us tonight and sharing your expertise in this area. It's been a really interesting one so far, and I think there's going to be some more interesting discussion to continue. But as I mentioned, for attendees, we will send a follow-up email, hopefully tomorrow or later this week, with the recording of this webinar. And if you do have a question, if you need to leave, please do just reply to that email and we'll make sure it gets picked up by the team. This is the last webinar we have planned for the moment, but please do let us know as well if you have any suggestions or kind of burning topic areas that you'd like us to address in the topic of home retrofit. I think it's been a really brilliant series of webinars, so if there's demand for more, we can certainly look into that. And yeah, otherwise, just a huge thank you to Paola and Tim and to all of you for joining us tonight. And if you do need to leave, please go ahead and we will carry on with some of the questions. All right, so I think I'm gonna, let me just check. What I'll do is if you put a message in the chat about specific home or question, I'll ask you to unmute and you should get something on your screen. We've had Benjamin, I know, is juggling children, so I'm gonna ask him first and check whilst he's still here. So Benjamin, you should now be able to talk. Do you want to ask a question?
Hi there, can you hear me?
Yeah.
So I'm purchasing a house in November, and it's got a very poor EPC rating. It's got barely any insulation at all. It's made in 1880. It does have some cavity around the exterior of the property, but it's probably one of the first sort of cavity walls that were created. So I've got some issues. One is that we can't put anything on the outside of the house. It's in a conservation area. And I can't put anything on the interior walls very easily because it will upset all the cornicing, the sort of detailed cornicing around the rooms. So I'm kind of left with a cavity wall insulation, but I was a bit worried on a house that's quite damp, putting cavity wall insulation in, and particularly in this sort of early cavity walls. Have you got any sort of advice? Do I need to get someone professionally to have a look at it, do you think?
I think that is the first thing you need to do. And actually, you have to find out why the walls are damp. Because if it's something that can be repaired, obviously you can do that. And then the end result will be a much better result and safer, etc. And it could be that it's rising damp, or it could be a gutter, it could be a whole host of things. So that's really something, the first thing that I would do. And then get, as Tim mentioned, the cavity wall companies will come and do a survey and actually check what the options are for you.
Okay.
And you're definitely right to be sort of cautious, because some of those early ones, and we've got some, the end wall is, is cavity, but actually is rubble filled, and they're very difficult to deal with. So absolutely just get someone in early and get, I would say get on there and book that kind of whole house plan, because your house is exactly the kind of stuff where, as I said, I had Natasha Ginks, who was on the previous survey, brilliant job of coming around and giving that initial view, and it just, we could kind of say, well, these are the areas we think are the issues, but that having that survey and the heat loss calculation stuff really pinpoints this is where you need to focus, and in your kind of building that's going to be important. And you said you're in a conservation area, but you're not a listed building, is that correct?
That's right, yeah, it's not listed, but it's
so I think in that case, again, get the experts in there, but you'll be able to do, I think, more than you think you might have to, because as I said, we're in that situation, and Hook Norton, we've got a sort of community group, and we're a conservation area. And when you're not a listed building, there's quite a lot of stuff that now you can do. And certainly, we've worked with a local council. So, for example, in a conservation area, if you're not a listed building, then still things like solar thermal panels and solar PV and things can be a permitted development rather than having to go through planning permission and things. So, again, the fact that you're in a conservation area, because you're not listed, I think that gives quite a few more options as well. So yeah, but look forward to hearing the next stages, and your case, particularly if you can get someone in really quickly before you start to move in, so you can get the work. Is there any possibility of getting work done before you move in?
No, I don't think so. But it'd be one of the first things we start doing before we do up the house. Yeah. So it'd be a priority to get the roof and the underfloor insulation done on the walls as well. So yeah, it's definitely. And
again, the whole house plan gives you phases of work, and at this stage, if you had it done now, so you knew what phase of work, then you can kind of really think about which parts of the building to move particularly into, and then and to do it in the stages. I can, by example, this back of the house coming off and stuff, we were out of the house thankfully for a period of time, but we did come back and camp in the other side of the house for a kind of a week and a half while the things are finished off. And it's that bit about moving around the house as well. So definitely crack on. But it sounds really interesting. We'll keep in touch.
Sorry, I'll just add something about that roof. If you are replacing a roof, that's a fantastic opportunity, because there is absolutely no impact on the conservation aspect of, and you can put a significant amount of insulation there, which will not cost you a fortune. It's not anything special. And the other comment I should say, which is linked to what Tim said earlier about we just have to get on with this. Cornices are fantastic, etc., but it's a question. It's a very important question. Is that more important than actually reducing your carbon footprint? And you can actually get them replicated.
Yeah, I know. I haven't looked into that yet, but it was just a kind of a barrier to doing something on the inside. But I guess I should think about it some more.
Yeah.
It's got very big rooms, very high ceilings, and so it's going to be bloody cold.
Yes. Sounds great.
Hopefully in the future, we'll see. Thanks for your help, guys.
All right, brilliant. Thanks, Benjamin. Okay, so next up is Alan Barlow. You should be able to speak now.
That's it.
Think you're-
Am I there? Oh,
Yeah.
right.
Need now.
Technology. Yeah. My curiosity is really, I've been retrofitting my house for the past 30 years since we've been here. And we've got a field out the back of our place where we live. And over the next 5 years, they're going to put 1,500 houses up on it. I just wonder what effect the wind will have, when it blows across it, if there's a load of housing in the way. Perhaps it's a bit of a strange question.
I would imagine you might get a benefit because
I know it's an all facing, the wind that comes across it's an all facing, but I just wonder what effect it might have on the rest of the house. That was all.
Yeah, well, it might actually sort of shift at a higher level. Usually if you get obstructions, you will get the wind will actually accelerate above those obstructions and will descend not immediately. So if you're within that sort of shadow of the wind,
right,
you will benefit from less wind, which means less air infiltration, less heat.
Right, it's just curious. It was just a curious question. Yeah, I know, but some people, if you don't ask these questions, people don't answer them, do they?
Yeah, fascinating question.
Yeah.
I mean, people put, shelter like trees and things to deflect wind, and you've got a whole bunch of houses. Maybe that's not the best option, but it's.
Well, I must admit, when we had the cold weather last year, the year before, I mean, because it's from the north, it came straight across the field, and we're 3 houses in, and it hit our house quite badly. But we wanted to insulate the outside wall, that side of it. So I was just wondering what was going to be the effect from it,
But if you're getting air in, it's maybe you might improve by trying to see where the air gaps are.
Yeah.
And actually taping those.
Yeah.
Or mastic or whatever.
Yeah. Right. Thank you.
All right. Thanks, Alan. Okay, we had one from Len, who is still here. Brilliant. All right, Len. Yeah, you should be able to speak now.
Hello there.
Hiya.
You can hear me.
Yep.
So what I said was that I've got a 1930s semi. So we've got about 200 millimeters of loft insulation, which I realise now I should double. We've got cavity wall insulation that was done, I don't know, maybe 20 years ago. So where's the next way to go? So we've got solar panels, but because the roof slopes on 3 sides, we've only got about 1.25 kilowatts, which isn't enough to heat the house really. We got gas central heating. Yeah. So is it worth lining some of the walls?
Well, so you said you've got cavity. So you probably, 1930s, you probably have a 50 mil cavity, which is not much. So there's definitely scope for adding insulation. I don't know. I mean, I live in a 1930s semi, and well, it's actually an end terrace, so there's a lot of wall, and I will end up insulating it on the outside, because the one advantage of this is that they're partially rendered anyway. So from a, not that the planning care, because it's not conservation or anything, but they do ask, Oxford does require people to put in, not require, but recommends people to put in a request for a permitted development. And you can actually insulate on the outside. Also, I don't know, again, 1930s, we have a huge, like a 400 millimeter roof overhang. So a lot of the issues with roofs having to be reconstructed or adapted don't apply.
So we do have that. So the problem with external insulation is we're in a row, it's not a conservation area, but we're in a row of 1930s semis, and we're the only house with the full set of stained glass windows left. So I need to keep the front appearance of the house to be as it was, really. Yeah, because it's the last one.
Yeah, no, that's fine.
Shocking.
And you could do that though then by having the external wall insulation and move the windows forward. I mean, there's there's all kinds of ways in which you can do that external wall insulation, how that relates to the windows. And the stained glass, you got any secondary glazing behind it, for example?
No, I mean, that's another question. So I'm going to get double glazing units in the front room. We have a row of stained glass across the top. So I need to put double glazing units underneath. So is it worth having secondary glazing behind double glazed windows as well?
You're not going to get that much benefit. The difference between double and triple is, it makes a difference, but as I said earlier in my lecture, it's really, if you go to that extent, it's either for sound or for, if you're really trying to get rid of central heating, then yeah, triple glazing is good. But if you're gonna have, so it's certainly not worth putting triple glazing in if you have a big single glazed element on the top of it. Then you're going to just have all the air go out there. There's no point. But I agree with Tim. If you're going to do that sort of, if you're thinking about, oh, I'm going to change the windows, then yeah, put insulation on the outside, move your window, reposition your feature window, and add something behind it as a secondary glazing just for that section.
See, I was thinking it might be easier to have insulation inside, reline the walls, because we were thinking about soundproofing as well, actually, in which case you'd line the walls against next door and at the front of the house. That was my
so you've got enough space, have you, Len, in terms of kind of adding in, say, 80 mil of insulation inside, that wouldn't cause any kind of issues internally? That's
8 centimeters, isn't it? That's quite a lot.
Yeah. Mm-hmm. It is. That's often the reason. I guess there's two reasons why. Yeah, there's a technical reason that Paola talked about in terms of kind of, in effect, it's a tea cozy effect. You put a tea cozy on top, it's much easier than trying to line the bits of the teapot and inside and doing the spout and doing the whatever. Maybe not doing the analogy too far, but that's one part of it. I mean, the other part of it, I have to say that's I don't know. It sounds like some of the houses south facing. Is also this bit about having not having overheating in the summer, having thermal mass. So if you insulate on the outside, you've still got that kind of that.
Oh, the thermal mass, is inside. Yeah. So in the summer, it's very hot, especially at the back of the house, and I have resorted to ripping up an old bed sheet to cover the windows on the outside.
Well, that's, I mean, I don't know about the bed sheet bit, but external shading is the best way to prevent overheating. And the other thing is, if you can, I mean, again, what Tim was saying about thermal mass, that I think it's really worthwhile keeping those walls to provide that thermal mass, which will absorb the heat slowly. But then what you really need is a way of ventilating, preferably at night, to get rid of any heat in the summer.
Yeah.
So that's, again, if you're adjusting your windows, then it's worth thinking about, okay, these are the things that I need. I need a better insulation. I need some way of ventilating at night, which is secure, and maybe even external shading.
I think at the back, maybe external shading, because the rear of the house isn't visible from the street. So, we can be I'm not so concerned about the conservation aspect at the back of the house.
Which way does it face those? I mean,
The back is southwest.
okay,
so
okay, yeah.
we have solar panels on the roof on the back. I suppose that's the other thing. Is it worth getting more solar panels? Have things changed enough in the, I don't know, maybe we had them for 10 years now. We were in at the beginning.
Yeah, I mean, it's interesting because we on the, you couldn't necessarily see there because ours are actually are east and west aligned. You know, with south face. The south face, we just haven't got the right roof for putting solar panels on there. So for a long time we didn't put them up there, but particularly now we've got an electric car to charge and the sort of heat pump. Then we've now got 3 kilowatts on there, and the price has come down significantly. And so if you've got more space, and because I agree, 1 kilowatt doesn't. Even if you're putting on things like your washing machine and your dishwasher and stuff, you're not covering everything from that. So that definitely is worthwhile. And the costs of actually, you don't get the same feed-in tariff you got before. You'll be consuming all of it. And so it's that's definitely something to look at. I mean, it does sound to me like, Len, you've got so many different options. What you need is a retrofit coordinator there with you so you can talk them through. It is one of those ones where we can kind of give you the different areas. It does sound like you've clearly
So do you offer that then? Because I'm actually not in Oxfordshire, if I'm honest. I'm across the border in Berkshire.
Yeah, no, Berkshire's close enough. We've got some retrofit coordinators that are there. If you'd said I'm up in Manchester, then we would struggle a bit, and we'd point you to Carbon Co-op. There's a sort of a somewhere up there, but no, we do go. Yeah, it's not a rigid border outside Oxfordshire where the retrofit coordinators.
The other thing is that my partner's just retired, and I'll retire in a year or so. So we're going to be in the house a lot more, aren't we? So we'll use more heating if we don't.
In that case, by the way, thermal mass is even more useful because it will help you in the heating season as well. If you need to heat a space quickly, thermal mass is actually detrimental. But if you're there all the time, then fantastic. But I think also not as a sort of bid for Cosy Homes, but what you get with the report is an idea of what the measures cost, what the payback is, what your carbon reduction is, and you can say, okay, I'd rather do this than that or whatever, and then you can plan together with the retrofit coordinator what your plan might.
So you've got my email address. Is it possible for somebody to get in touch then?
Well, I think the route there, Len, is if you go on the Cosy Homes website and register for a whole house plan, that would be the quickest way.
Oh, okay. A whole house plan.
Yeah, so and there is a fee for that service, just to be clear. So it's £175 for having someone on site and doing that.
Yeah. How much are we talking, roughly?
£175.
I don't know. I suppose I could cope, couldn't I?
Well, for me, I paid that at the start. And
that's fine.
It really does provide that framework. So I would say it's it adds an awful lot. So when you've got the number of different options you're talking about, I think you'd find, and it's not just it's part of the report, but it's that bit of having, we've sort of talked through it and sort of we've got a picture in our mind. Certainly, I work in pictures, so I've got a sort of picture in my mind of your house, and I've been kind of thinking about that. That picture could be completely wrong.
Oh, absolutely.
And if you write up there, it might be give different advice. So it is very worthwhile.
Yeah, I think that's the best thing. I'll do that. That'll be good. Great. Well, thanks a lot. It's been very good, I think. I don't know if people do give you enough compliments, but I will get in touch. Right. So thanks a lot.
Right. Brilliant. Thank you, Len. Okay, so we did, Claire's still here. All right, Claire had asked a question about her house as well. I'll just allow you to talk.
That's a hell of a power you have.
Yeah, I know. There we go. I think you should be able to talk now.
Yeah. Hello.
Hiya.
Hi. Tim, actually, we used to work together, I don't know, a long time.
I was going to say, I wonder whether it was the Claire Downing. Yeah, how are you?
I'm all right, thank you. How are you?
Very well, very well.
We've been listening to all your, we were listening to the one last week as well, so that was good.
Okay.
So we've had a survey, a whole house plan, and but the issue with finding is that anyway, so we've got a 1920s house, but we've got a timber upper story and a brick base, as it were. So the first, the ground floor is brick, and then it goes to timber for the bedrooms. And then nearly all the bedrooms have got some sloping roof and some flat roof, you sort of mean. So it's a real mixture of, there's a bit that's in the loft, so you can, there's a bit of loft space, but the slopey roof of the roof goes into the bedroom, if you sort of mean, and then the wall is all still timber. So we are thinking about taking off the whole lot, sort of mean, so it's all tiled with all the same tiles, so the wall and the slopey roof, and then obviously the main roof as well. And then one bit of the house has got a flat roof, so it's got I'll try and describe it, but it basically goes up and then it goes down and then it goes across, and there's a flat roof in the middle. So we've got 3 rooms across the front. So there's 2 slopey roofs, as it were, and then there's a flat roof in the middle, and then there's another slopey roof on the other side. And the flat roof at the moment is leaded. Anyway, we've got it's complicated to try and get that all insulated and have no bridges and have windows that we're building out. We are replacing the windows so they can build out the sills, but they're not quite sure what to do about the flat roof.
So are you
certainly, on the pictures I had, and if that ceiling up there, for example, is the kind of, as you say, it ends up, it's that kind of the slopey roof bit and it butting on, and it's similar but different. That kind of whole, it's a timber frame that you can see behind with then there wasn't enough insulation in the wall bits in the middle beforehand, and it was really a matter of basically just taking that out. I have described it basically as taking the middle section of the back of the house out and putting it back in again. It certainly is disruptive, but that by doing that, which sounds like the kind of thing that you're talking about with the Retrofit Coordinator, what I can say, it is really worthwhile, because the whole feel of that central section now in terms of insulation, it used to be the coldest part of the house. It's now it's the most comfortable part of the house. If you're changing the glazing again, if you are changing the glazing, while agreeing with Paola, it is worth. I would say it is. We went for this triple glazing just because we knew we wanted to do that there, and it has actually made a significant difference in things like the sound. And interesting enough, something I hadn't really thought about before, but with the triple glazing, you actually, how that effect you get in a car, which is that cold surface, and you get the condensation early in the morning. You can see that on some of the mornings where you've got the humidity, so you can tell what the difference. You never get that with double glazing, so that kind of extra level of insulation as well. So it does sound like the bits you do. The specific bit about the flat roof there. You probably saw we've got all kinds of different bits in and out of the roof, and getting again that all done at the same time does produce, stop the bridges that Paola was talking about. So I've probably said too. You probably need to more have the expert Paola talking, but it sounds quite similar. And
I was just going to ask whether it was your bits. By the way, there are loads of roofs in Oxfordshire where you have the I didn't even know it had a name, but apparently they're called skeelings, where the roof is actually part of the
Exactly.
Yeah, that's now there's also a question of how, as Tim is saying, are you happy to take off a whole watch? It is very much with this cozy homes business. Some people don't really want to do huge amount of work, and some people do. If you do, then you have a cladded external. You have tiles on the top.
Yeah.
It's usually the case that if you were up for it, you can easily insulate on the outside of take the tiles off, put the insulation in, and retile it.
That's right. That's what we're planning to do.
Yeah, which is great.
One of the reasons is because the tiles are 100 years old, but they're also asbestos. So we would bin the tiles, and but obviously we'd have to have them properly, sent
safely. Yeah.
Yeah.
Which means that you are wrapping the actual structure with your insulation, which is the best solution that you can go for. And so really, if you're going that far, you should probably just remove the finish of the flat roof, look at whether you can insulate on top of that and actually make the insulation continuous that way.
Yeah, and so we would have they've said we would have to increase the ridge height of the bits that have got ridges in, but then we'd also obviously increase the flat roof height. Is that, I assume that's not a problem, you just slightly change the roof line?
Yeah, it depends where you are, but technically there's not a problem. There may be some legal implications depending if you have, I don't know, where are you in a, do you have neighbors or?
Not very close neighbours. We're in an area of outstanding natural beauty, but I think it's fine. We're not restricted. We're not, you know, we're not as restricted as a conservation area, is what I would say.
Yeah, I mean, you'd have to check with the planners, but if you're saying we're raising it 200 millimeters, I doubt that. I don't doubt anything about the planners, but I would hope that they would be sensible.
Okay.
But it does sound like, think of what Tim said, cozy, tea cozy. That is the sort of idea of what you're trying to achieve.
Yeah, and two other questions. I assume, would we need to move out? Because actually the way the structure, so we've had a boroscope survey already, and basically we've got nothing, as in there's plasterboard, thin air, battens and tiles. Okay, so there's, if you've taken the tiles off, all we've got is the plasterboard.
Yeah, this is something else I found in other places as well.
So it's quite very well ventilated at the moment, as well.
Whether you want to move out or not, it depends on whether you like living in a building site or not, and whether you have other places you can hide in the house.
Not really.
No.
In the sense that we've got 3 bedrooms and we got 2 kids, and you know there's 4 of us in the house, so every room is used every day, pretty much.
Yeah, I can give some personal. I think we had that naive thought that, you know, first we thought we might do this around sort of springtime, and that we might be able to sort of hide in the back of the house and do that. You know, as you know, there's a Trish, my wife teaches, and so it happened to work out that we managed to get the timing so that we could be away. And we basically spent a month in a camper van away, and you know, we then came back and just had a week where we were camped in that room there. You know, it's certainly the idea. I think it was clearly, as you know, looking back on it, I mean, I can put up with mess quite happily generally around that. So I might just got a coat, but I think Trish would have gone completely mad around the bit there. So I would say, moving out in some form, if you're having that much done, would help your sanity.
Yeah,
I think if you have kids, that would also be my advice.
Yeah, well, we've also got, theoretically, it depends on when it's done, but she's got GCSEs this year, so yeah. Anyway, one other question, we've got metal windows at the moment, single glazed metal, you know, Crittall. And should I do double or triple? And what's the cost implication?
Well, we were discussing that the cost difference isn't that great. And if you don't have, if you don't mind spending that little bit extra, there's no reason why not to go for triple glazed. And yeah, I mean, single glazed metal windows are probably the worst you could have.
Yeah, it's quite drafty.
Yeah, I mean, given you're having to, I think it's one of those ones where, for me, and particularly having gone through it, if you're having to, you know, replacing we even replaced one failing double with a triple, and that's made a significant difference on a north-facing room. Replacing a single, I would absolutely, you know, unless there's a real issue around budget that would stop you doing it, absolutely go for triple. You know, I've been surprised what a difference it makes, because we've had double around generally, but not triple. And if you're replacing it, to me nowadays, you know, unless there's a real issue around short-term budget, definitely go for triple. It makes a significant difference, and that can be, there's a company, we had ones at the front that needed to be conservation area that were manufactured in Buckinghamshire. Fantastic job there. And then the ones that were behind were sort of very slightly larger ones, and so to get the U values right down, they've come from Austria. So there's a range of different ones to go for, but I would definitely go for triple, having gone through the process. And I wouldn't, that's not something I had thought I'd be saying before we had it done, but having had it done, definitely worthwhile going for triple.
And what are there any implications in terms of what's in the windows, i.e. the environmental sustainability in terms of, you know, when they're disposed of or anything like that?
Not any different to double.
No.
Yeah, there's no difference. I mean,
Because there's different gases in them, isn't there, and things like that?
not necessarily. They have a variety of gases, but they're the same detrimental effect as the double.
Yeah, and the gases are inert gases, so they're kind of, you know, it's none of the CFC type of issues. I mean, yes, there's an energy, embodied energy, but the operating energy that you're saving will, yeah, the energy payback you'll get back much more rapidly. So on an energy, definitely on an energy basis, go for triple.
Right. And does Cosy Homes have, you know, these suppliers that will do them, or do we would have to source them ourselves?
So did you say you've already gone through the Cosy Homes, you've got the Cosy Home reports and things?
Yeah.
Yeah, well, absolutely goes through that's one of the things that we do as the next stage. So having had the report, the suppliers came through Cosy Homes, but definitely if you want to have that done and have it done soon, as you might imagine with the Green Homes grant, we are being inundated. So get in the front of that queue, because we're in a good position compared to lots of parts of the country, but we are already, I mean, the chap that put in the air source heat pump would be, as a community, has been our go-to person, has had to send out notes to people now saying, look, we're just so inundated, we're not going to be able to help put in anything until sort of February time. So, if what you want to do is do it now and get the Green Homes grant, we're not going to be able to help you. So, and we've got different suppliers that do contracts to do different bits. But if you want to do it sooner rather than later, then get cracking.
Yeah. Have you got you haven't got your building performance specification? You haven't.
We have.
You have that as well.
Yeah.
Ah.
And we've put. Well, no, I need to talk to somebody about this anyway. But I was gonna. So that was put through in August to Cosy Homes, and we've had no quotes at all yet, which is a bit odd. Is what I would
So
say.
if you've got my email, then just follow through and with via Tabitha, and we'll follow it through, because it's and again it is one of those, again no, in one sense no excuses, because we just need to make sure these things go through. And if you have that stage, you are absolutely the people who want to get through to the next stage, Claire. So it's sort of for all kinds of reasons, let's make sure we keep in touch. But if you've got that far down the line, absolutely, we want to try and get you through to having the work done.
Okay. So what do I need to do then? I need to send you what? So to mean?
just send me the email with your Cosy Home number on. That's the easiest thing. On the front of the report, I'll tell you what code, but I should be able to find it anyway. More than anything.
Yeah, we can find you. Is that it's like if I find you in our system and pass you on to Tim, then we can make sure we follow up with you. Does that sound okay?
Okay. Yeah, that sounds great. Thank you.
You don't have to worry about it. All right, brilliant. Well,
Great.
I hope that was helpful.
Yeah, great. Thank you.
Great, thanks, Claire. Okay, I think that was everyone who'd asked a question about their house, but please do shout at me in the chat if you're still here and you had a question about your home. We did have one question, I guess, leading on from the end of that discussion on the Green Homes grant from Rico, which we might as well just cover whilst we're here. And Tim, I think this might be one for you with your MCS hat on. So I'll just read this one out. But Rico is asking, how do you feel we can ensure more people can deliver the Green Homes grant? Because we know we have too few people Trustmark and PAS 2030 qualified, which means we're struggling to fulfill retrofit work. Are there any other qualifications you feel should be appropriate? For example, he said passive house designers are not seen as qualified by the government standards.
It's one of the best bits that's come out of the Green Homes grant is there's a training program that they put in £2.5 million, I think, into a training program to get people skilled up, and also to be past 2030, which is the bit around the kind of the technical around the management standards around the kind of areas around installation things, and then the other part of it is moving people in using renewable heat. Is the MCS, being MCS certified, so you're Trustmark registered, MCS certified. So there is a training program to make that happen. So we've then got more people going forward. There's also, certainly in terms of retrofit coordinators for Cosy Homes have come from a whole range of different areas and backgrounds, and we're certainly think it's really important not just to view us as having retrofit assessors that have done energy performance certificates and EPCs and that sort of things. The sort of people you say with those qualifications absolutely are what we want to bring in. And certainly if you've got some examples of people that are particularly in the area here, those are the type of people that we'd fast track so they can become retrofit coordinators quite rapidly. It's recognizing that different people come into it with different skills, and there's the type of example of the people you mentioned there, we could fast track very rapidly and get into being able to provide the support that's needed for this. Does that, hopefully that answers the question. If you want to come back and ask anything live, or Paola, I don't know if you want to add anything on that.
I think it is a problem, but as you say, the government is trying to put money in to support it, and hopefully the green grant may be extended. I don't know if it will, but
fingers crossed.
Yeah.
Great, thank you. Yeah, Rico, if you do have any follow-up questions on that, just drop it in the chat and I'll let you speak. I haven't had anyone else shouting at me in chat, so I don't think I've missed anyone. Oh, Rico had an additional question. Can rendered homes use EWI, external wall insulation / diathanite, or does the layer of render need to be removed first?
If the existing render is in any way dodgy, then like it's falling off or brittle or whatever, then yeah, it has to be taken out. If it's a cement-based render, there may be, you would want to get advice in case it might cause problems later on, but otherwise there's just a practical aspect of when you actually install the external wall insulation, it needs a reasonably smooth surface to fit to, and it should be well stuck without any air gaps, which would be thermal bridges fundamentally, or bypasses. So yeah, if you put a layer of diathanite, for example, and then fix the external insulation, that would be fine. But the substrate has to be sound and dry.
Great, thank you. Oh, Rico's saying thanks as well. Okay, I think that covers all of the questions. If any of you who are still here do have any additional questions, just drop us an email and we'll answer those. But I think that's it for tonight. And thank you, Paola and Tim, for sticking around, and to the 7 attendees that we still have with us right to the end. It's great. I think these discussions at the end are really, really valuable. It's really interesting to hear about everyone else's houses and the different issues, and it does kind of highlight how every house is unique and the importance of actually going and looking at them, doesn't it? So yeah, thank you everyone for coming, and we'll finish up now.
Great, thank you very much. Yeah, great questions. Yeah, it's stimulating at this end as well, definitely.
Yeah, definitely.
Thank you both, and the audience that is left dwindling away.
All right.
All right.
Good night, everyone.
Goodbye.
Bye.
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 Bye.